back. So the question here is, four identical hollow cylindrical columns of mild steel support a big structure of mass 50,000 kg. The inner and outer radii of each column are 30 and 60 centimeter respectively. Assuming the load distribution to be uniform, calculate the compressional strain of each column. Inner radii of each column is which is denoted by R1 is 30 centimeter, which is 0.3 meter. Outer radii of each column R2 equals 60 centimeter, which is equal to 0.6 meter. Mass of the structure M equals 50,000 kg. So the stress on each column is capital P, which is equal to 50,000 into 9.8 divided by 4 pi into 0.6 squared minus 0.3 squared, which is coming out to be 1.444 into 10 to the power 5 Newton per meter square. Young's modulus of steel is Y, which is equal to 2 into 10 to the power 11 Newton per meter square. The compressional strain is P by Y. Now the value of P, if we put the value of P and Y, we get it to be 7.22 into 10 to the power minus 7.